Hello, everyone. Welcome to our Programming Assignments and Code Autograder Gradescope webinar. Thank you all for joining. We will start about 2 minutes after the hour. So thank you to everyone who's here. All right, I think we will get started. Thank you again to everyone who's joining us for our Programming Assignments and Code Autograders Gradescope webinar. My name is Olia Stady. I'm the product manager for Gradescope. And today I will be co-presenting with Ibrahim Awal, who is one of our Gradescope co-founders and currently principal software engineer. He also actually built our Code Autograder platform. So he is the best possible person to talk to you guys about Code Autograders. And in the Q&A, you may see Stephen Kaminsky. Stephen is one of our software engineers, and he is formerly a Gradescope power user. He used Gradescope as a computer science TA at UC Berkeley and built Code Autograders himself. So just a few housekeeping things. All of you are muted, but if you have questions throughout the webinar, please post them in the Q&A. So if you hover over the bottom of your Zoom window, you'll see a Q&A window. So just put all of your questions there, and our team will be there responding to them throughout the webinar. We'll also save a few of your questions for live Q&A with Ibrahim in the last few minutes of the webinar. Please use the Q&A and not the chat, since the Q&A is a great place for us to triage different questions. Post your questions anytime during the webinar. We'll get to them throughout. A recording of this webinar will be available afterwards. It will be sent to all of you over email, probably at the start of next week. And this webinar is intended for people who have some familiarity with Gradescope and want to learn about building Code Autograders. If you're completely new to Gradescope, please go to our Getting Started page, and there's lots of videos about basic things like creating courses and creating assignments. So the structure of today's webinar, I'm going to start by giving you guys like a 15-minute walkthrough of the general Gradescope programming assignment flow, just for those of you who may not be familiar with all of the actual Gradescope functionalities. So creating an assignment, submitting as a student, looking at the autograder results as a student, manually grading code, and code similarity. And then I will pass it over to Ibrahim at about the 15 or 20-minute mark of the hour to walk you through concepts around code autograders, how to set up a code autograder, and tips for setting up code autograders for Gradescope. And then we'll walk through an example of a Python autograder, and if time, a Java autograder. And then the last 5 to 10 minutes will just be Q&A with Ibrahim. And again, please just post your questions in the Q&A throughout the webinar. We might save some of them for the end, and we might respond to some of them during the webinar. So lightning round of what is Gradescope, just to get us all in the same place. Gradescope is a tool where you can grade anything, whether it's instructor, student uploaded, any type of assignment online. So exams, paper-based homework, code, etc. You can use any assignment that you already have in your course and adapt it to work with Gradescope. Works both for paper-based and digital submissions. And the general flow that I'm about to show for code assignments is that students submit code to Gradescope in any programming language. The instructor grades the code either via a pre-uploaded autograder or via manual grading. You can check for code similarity as well. You can get the grades back to the students and see statistics on how the students did. So when we talk about programming assignments in particular, as I mentioned, the student's going to submit their code. We are a language agnostic platform, so any programming language and any code file and file extension is supported. Students can submit via file or via GitHub or Bitbucket integration. The files do need to be student uploaded into Gradescope. And then when it comes to grading the code, you're basically going to have an option of either setting up a code autograder, which is what the second half of this webinar will focus on, manually grading the code, which means actually looking at the code and giving inline comments and using a Gradescope rubric, or using both. And the majority of our computer science and engineering users do use a combination of code autograding and manual grading. So with that, I'm actually going to jump straight into the Gradescope interface and quickly walk us through the general flow from start to end of creating and grading a programming assignment. I will skip over the part where we actually build the code autograder, since that will be the focus of Ibrahim's presentation and the second half of this webinar. So I'm inside a sample Gradescope course. The course already has a roster of some students. And I'm going to go ahead and create a programming assignment. And I'll just call this is going to be a Python assignment. The assignment that I'll be creating uses the same autograder and examples that you will find in your Gradescope 202 advanced demo course, which is a course that's preloaded on all instructor accounts on Gradescope. And the assignment is basically just a Python assignment where students need to write a calculator program in Python. Ibrahim will actually dive into the code of the autograder for this assignment later in this webinar. But for now, we're just going to actually create the assignment on Gradescope. So I'm going to call this Python assignment. You do have an option of both either autograding the assignment, manually grading it, or both. In this case, if you wanted to only manually grade, you would just enable manual grading and set the autograder points to be 0. If you wanted to only autograde, you would just set the total assignment point value. Let's say that's 90. And in my case, I am going to enable manual grading and set some autograder points. Rest of the settings are just general to all Gradescope assignments. When do I want my students to be able to submit? And one option that's unique to programming assignments is leaderboards. This is common in an environment where you want your students to compete against each other. So leaderboard will basically allow your students to see each other's autograder scores, either under their name or under a selected anonymized name. So it's a way for students to compete against each other and try to write code that passes more tests than their classmates. So if that's relevant, you can enable the leaderboard. If not, you can keep that disabled. So I've now created this assignment. Let's walk through our flow. On the edit outline page, I have my autograder question, which is just the number of points that the autograder will grade out of. If I want to manually grade, I'm just going to add as many manually graded questions as I want. Let's say that I want to manually grade 10 points of this assignment for the style of the code and 90 points through automated autograder tests. My next step is the step where I configure the autograder. This is what Ibrahim will jump into in the second half of this webinar. For now, I am just going to skip over how I built the autograder and upload an existing one. So I'm just going to select an autograder from my computer. It's in a zip file. We do now, for those of you who have used Gradescope before, you'll see this part is new. We do now have the option to select the base image that you want to base your autograder off of. The default is Ubuntu 22.04, but you can select older Ubuntu base images as well. In the future, we'll be adding more base image options here, such as Fedora and a few others. And you can read more about our base images and which one to select in the documentation that's linked on this page. So I'm now uploading my autograder to Gradescope. It'll process, and that usually takes a few minutes. But in the meantime, we can actually, once we've uploaded our autograder, our assignment is ready for our students to complete. Typically, we recommend testing your autograder once it's been uploaded with a sample student submission, just to make sure that all of the tests pass and all the tests that you don't want to pass fail. So just testing with a few submissions. And you can always replace your autograder, download the file, or update your base image by replacing the autograder. So I'm now going to jump over to a student side. And as a student, I will see all of my programming assignments, including this Python assignment. I'm actually just going to upload to a copy of this where I've already uploaded that same autograder, just to make sure the autograder has fully been uploaded on the instructor side. And as a student, when I click on an assignment, I'm going to get 3 options for submission. I can either drag and drop my code files into this drag and drop window. I can connect my GitHub account and select a repo and a branch, or do the same for Bitbucket. We do have a new feature now where students can connect their GitHub and Bitbucket account before any assignments are available. So from their account settings page under Edit Account, any student can go into Edit Account, connect their Bitbucket or GitHub account ahead of time so that they have that ready for when they're ready to submit an assignment. We also now have the option for students to link multiple GitHub or Bitbucket accounts to the same Gradescope account and to unlink and relink. It's all from Gradescope. So I'm going to go ahead as a student and upload my autograder file. My file is called Python Calculator Mistakes because we want to fail a few tests for the purpose of the demo. Hopefully your students would upload a perfect code file that passes all of your autograder tests. And my file has now been submitted. And now what's happening is in real time, your autograder that you uploaded as an instructor to the assignment is running on the student's code so that within the course of a few seconds to a few minutes, depending on how many tests you have, how big the code file is, and how fast the student's internet connection is, the student is going to see results in real time of which tests they passed and failed. And while they're waiting for the results, they can also preview the code that they submitted. So this is my Python calculator program code that I just uploaded. And you can see within the course of a few seconds here, we now have our results. So students see the results in real time. So the big benefit here is that you don't have to wait for all of your students to submit, then download all their files and compile and run them on your computer. Students get their feedback as soon as they submit their code to Gradescope. And I can see, so these rows here are all the unit tests or the test cases that were defined by the instructor's autograder. And you can see for this Python calculator assignment, my test cases are just, does the student's calculator correctly evaluate 1 + 1? Does it correctly evaluate 2 - 1, etc.? As a student, I can see that I've passed the tests in blue and I've failed the tests in red. So I can see, for example, that 2 times H should have raised an exception in my code, but it did not. So all of the points and the test cases and the custom feedback that students see is defined by you and your autograder. You can also hide certain test cases from students or all of them. And by default, students can resubmit to try to improve their code based on this feedback, but you and your autograder can also control how many times they can resubmit by using rate limiting schemes. So going back to the instructor side, I now have that student submission in here. Hopefully, if I refresh, actually, I'm going to go to the assignment where that student submitted. So I have that student submission in my manage submissions page. I've also uploaded a different student submissions here. From the manage submissions page, you can always, if you want to update your autograder, you can always regrade all submissions and rerun your new autograder on them. You can upload a submission on behalf of a student by selecting their name, and you can proceed to grading. So the grade submission step will only appear if you're doing manual grading. So if you selected that manual grading box when creating the assignment, and when you grade, you're going to see every student submission one by one, with this is submission 1 out of 2. I can actually look at their code, and if I'm grading for style, I might want to click on a line and leave an inline comment, such as needs more commenting. I can go through line by line and leave feedback on the student submission. I can also build a rubric with items that have point value deductions and or awards by switching it to positive. So I can say, for example, does not follow AP8 style. and maybe apply that to the student. Maybe that's -2 points, etc. So this is just a standard Gradescope grading interface, but the one feature to call out here is that you can leave inline comments on any line of code. And if you do have an autograder, you can also have your autograder results here. If you're new to Gradescope and you're just getting started and you don't have time to build an autograder, your students can just submit any code to a programming assignment, and then you can just skip the autograder component and grade manually. So an autograder is not required. Finally, once all the grading's been done, we can publish grades to our students. We can post them to our LMS if our institution has an LMS integration. And on the student side, we can see what the code is going to look like. Let me make sure that I've published everything correctly to my students. I didn't grade my second submission. That's what happened. So once I've graded my first student submission, I can go to the next one. I'm just going to give the student also a 8 out of 10. Grades are published. Great. And as a student, once grades are published, I will be able to see my autograder results, my score, and the rubric for the manually graded question. And if I look at my code, I will also be able to see any inline comments that were left on the code. Back on the instructor side, I can see statistics. So for my autograder, I'll be able to see what % of students got each of my test cases right and wrong. So that can be really helpful to see if there's common mistakes that students are making on the assignment. And I can review for code similarity. So when I go to the review similarity page, unlike the autograder, which supports any language that can be run on a Linux-based system, code similarity is currently only available for a few languages. So all of the languages that you see in this dropdown here. So in this case, I am using Python, so I'll select my language. The template file is an optional place where you can upload starter code. So if you have an assignment where you're providing some starter code to students, and all of the students are going to have that code and are going to build on top of it, you can actually drag and drop your starter code in here so that that is not flagged as a similar match across all students. Our code similarity engine uses MOS, which is measure of software similarity. It's a open source AI-based code similarity matching software from that was built at Stanford. In this case, these are not very exciting results because I uploaded the same submission twice, so the two submissions are 100% similar. But we can look at the similarity report for a different assignment where I had a few different students submit. So once the results process, you'll see the number of strings of code that match across the two students and the % similarity. So my dummy student Rose has 42% similarity with my dummy student Paul. And I can open up the report and see Rose's code on the left and Paul's code on the right. And the lines of code that are the same are highlighted. So line 45 to 61 of Rose's code is the same as line 81 to 100 of Paul's code. And you can see that even though the code snippets are not, the strings of code may not be exactly identical, because we selected the programming language, the code similarity engine actually knows the structure of Python and is able to flag similarity, even if it's not at the string level. So some common tactics that students might use to try to trick the similarity checker is adding a lot of inline comments to make their code look different visually from their partner's code, or renaming their functions or their variables, and Gradescope Similarity Checker will catch that. I can also see now that Rose has 26% similarity with a different student, Byron, and 23% similarity with Dale. We can print these reports, and just to be clear, we never want to tell the instructor that there is plagiarism happening. This is just a place where we can flag similar snippets of code and have you make your judgments on what that may indicate about the student's behavior. So that is my deep dive in my, my overview of Gradescope programming assignments in terms of the instructor and student workflow. A couple of other things to note is that, as I mentioned, any code files of any extension can be uploaded. You can also have students upload like a PDF file and a code file to the same Gradescope assignment. Another common thing to do is to have students upload Jupyter notebooks. So basically any type of files with any extensions can be uploaded. The only language restrictions are going to be for reviewing similarity, which will only work with these languages. So with that, I am going to stop sharing my screen and pass it over to Ibrahim, who's going to take us on a deep dive of how to actually get that code autograder set up. Since I know we skipped over that, we just assumed we had an autograder. So for the rest of this webinar, we're going to do a deep dive into the structure of code autograders, suggestions, tips, etc.
Hello, everyone. So I'm Ibrahim. Can someone just confirm for me? Can everyone see my screen? The slides?
I think you're good.
Awesome. Thank you. Awesome. Okay. And so today I'm going to talk about how to build a code autograder for Gradescope. And I'm going to start kind of from the basics because I don't want to assume anything on anyone's part, and I want to make sure that we're all on the same page. So we'll start from the very beginning. What is autograding? And at a very high level, the idea is to take some kind of code input that your students have submitted, pass it through an autograder, which is some kind of black box, and we don't know what's inside it yet. At the end of it all, produce some kind of output that tells the student how many points they received and any other information that you want them to know about it. So what actually goes inside this autograder box? That can be a pretty vague thing. It really depends on the assignment, unfortunately. But I'll kind of outline some suggestions or ideas about how you might want to structure your autograder. The most important thing is that the autograder should be a program that can run by itself. So you set it loose on your student's code, and it should return some output without any intervention. Ideally, you want the autograder to be more or less consistent, objective, so that if the same student submits the same thing twice, they should get the same score, or if two different students submit the same thing, they should get the same score. But that doesn't necessarily have to be the case. But especially if your assignments can get more complicated, there might be good reasons to relax that constraint. But beyond that, you can really do anything that you can do with writing code to evaluate your students' code. And so, a few different things that people can do is, check the return values of functions, checking output that's produced, comparing files that are generated by the student's code, etc. And so I'm going to start from some really simple examples. So apologies if the examples are very basic, but I just want to make sure that we can kind of have something that we can talk about and discuss during this process of this presentation. Because I know that any examples I give are going to be very different from what your actual assignments are. I have my examples written in Python, but your class might be in a completely different programming language. So I'm going to try to talk about generalities in the beginning so that we can kind of all understand how it might apply to our own assignments. So there's a lot of ways that people tend to structure autograders. There's a survey paper that's listed down at the footnote over there that has some different ways. Some of the most popular are sort of unit testing based autograding and diff based autograding. And unit testing is a well-known software engineering technique where you essentially exercise different individual units of code by themselves. That could be, functions and classes or any other organizational unit of code, and then check the behavior to see that the behavior of that code is what you expect. So, things like calling a function and checking that it returns a value you expect given the inputs that you provided. And of course, it can get more complicated as your projects get more complicated. The other option that is somewhat common is a sort of diff-based approach. And when I say diff, I kind of mean the Unix program diff, where you just compare two different files and check that they match. And the idea with that is essentially, so some types of programs will produce some sort of output, like a output text to standard output, or maybe even say image files or something like that, or other generated files. And the idea there is to just check that the output that the student's submission produces matches the reference solution. And that could be, you could potentially either provide, in your autograder, the actual expected solution output, or it could be that you have a reference program that's kind of alongside your autograder, and you just pass it the same arguments that you pass to your student's code, and check that the output matches. So there's a lot of different ways you can set those things up. And then some other approaches that can also be used are things like integration testing, where kind of, instead of just unit testing individual pieces of code, you're testing the whole project together. And typically you would kind of have a little bit of all of the above in your autograders, because you want to make sure that it all works together. And you can kind of think of this diff-based autograding as a sort of type of integration test. Another type of testing that's commonly used is acceptance testing. It's kind of just a specific nomenclature for a specific type of testing. For certain types of assignments, you might use interaction automation, such as like browser or UI automation. For instance, like if your assignment involves writing a web page, you might have your autograder might interact with the student's web page using something like Selenium. There's all sorts of things that you can do here. The good thing is that because your autograder is a program that you write, so you're pretty much unlimited in what you can do as long as you can write code to do it. And so at a high level, the general recipe for building an autograder kind of goes like this. So, before you get started, you need to decide what exactly you want to test and how you're going to construct the test cases, like what kind of inputs you want to pass or how to set up the environment for to actually execute the student's code. And once you've done that, you want to define any setup needed to prepare your testing environment, such as setting up different packages or libraries, or other like data files. Then once you have your autograder environment ready, you will need to define your test cases. And so the test cases could be doing things like setup, any kind of preparation for each individual test case, exercise the student's code, verify the results of the student's code, and then tear down any resources that need to be cleaned up. And those four specific words come from the four-phase testing pattern, but you don't necessarily have to follow any particular testing methodology. Essentially, anything that you need to do to evaluate the student's code and produce some objective result is anything you can put inside your test cases. Once you've run each test case, you will need to store some kind of data about the test result. So like, did the test pass or fail? How many points did the student get? What was the test trying to test? Some kind of description so they know what exactly happened. And any other information that you might want to present back to the students. And then at the end of the process, you would need to output some kind of message or some kind of UI to the students that would give them the information that they need about what score did they get and anything that you want them to know about their test results, such as which test cases passed, which test cases did not pass. And that can be as vague or as specific as you want, depending on how you want to set up your assignment. And so just to kind of make that a little bit more concrete, I'm going to show us a really simple code example. So this is a Fibonacci. So the idea of this is, like, let's say your assignment is like write a function that computes the Fibonacci sequence. And so on the right-hand side, I have sort of the student's code. And the nice thing about this example is that it all fits on one screen. And then, so on the left-hand side, and all around it really is the testing code. So just to kind of show how, like, illustrate the structure that you might have, you would need to start by somehow including or importing your student's code into your autograder so that you can execute it. In this case, in Python, I have an import statement. The next relevant feature is that I'm keeping a list of test results to keep track of how things are going so far. And you can use any data structures you need, but in Python, at least, like, this is a simple data structure that's useful for this. And then each of my test cases, in this case, is just a function. And inside each test case, I'm calling the student's function with a particular input and checking that it matches a particular value. And then if the test case passes, then I append certain metadata that awards points to that results list. And if it fails, then I will append the metadata that does not award points. And so have that same thing repeated a bunch of times, or well, with different input values. kind of representing different test cases. And then at the end of it all, I have sort of main function that prints out the test results at the end of the process. And then this is kind of some sample output of running this really simple autograder on a student submission that did not achieve full points. And so the reason I have this really brief example is just to show that you don't necessarily have to use any particular testing framework or methodology or like anything too fancy. You don't have to use anything that's pre-created out there. If you're just getting started and you're kind of maybe like just not sure what to use, it's totally valid and totally great to just go really basic. Just use sort of built-in data structures in your programming language to do your own bookkeeping. Use like simple organization methods like functions and classes. You don't have to go down the whole path of using a particular testing framework that already exists out there. And there are actually pretty good reasons not to do that anyway, so we might talk about that in the future. And so from this point on, we'll be talking kind of about that calculator example that Olia was showing. As we mentioned earlier, the idea is that the calculator program should respond to inputs that the user types into the prompt, and it should evaluate them. It should handle parentheses and negative numbers and operator precedence. And then if user types quit, it should exit the program. I have a little GIF of the calculator program interacting. But if it plays, it seems like it's not playing, but you kind of get the idea. So, there's the user can type in inputs, and then the program should respond back with the return value. All right, and this is the starter code for that project. And the important thing about, you don't necessarily have to provide starter code to your students, but the benefit of doing this is that you can standardize on the API that the students are following. And that way, when you write your autograder tests, you know that you're testing these specific functions, and you don't have to worry about how the student might have organized their code beyond that. And it also makes it easier for the students to kind of get started and just fill in the blanks. And then in this case, I'm going to show some unit tests using the Python unit test library for that calculator project. Again, you don't necessarily have to use this particular library. You don't have to use Python, but if you want to, it's a pretty good option that's available for you. So we import that library. This is built into the standard library. And then we define our test cases here. So in the setup phase for this particular test case, all I need to do is instantiate an instance of the student's class and kind of store a reference to it. And then each test case that I have is going to just call the student's calculator function with a particular string input, and then check that the value that it returns matches what was expected. So obviously 1 + 1 = 2. 1 + 1 in parentheses times 4 is equal to 8. So this is kind of testing that parentheses precedence works. And then this is just to test that operator precedence works, and multiplication takes precedence over addition. And so in general, if you use some type of unit testing library, they'll probably have these types of assertion functions where you can check values, and if these assertions fail, then the test will fail as well. Oh yeah, and so this is the importing the student's code, setting up that student's class, and testing the student's code. All right, so that's kind of a general overview of some really basic principles of writing autograders. So if you have any questions about any of that, please feel free to put them in the Q&A section, and we'll try to get to them either now or at the end of the presentation. And so now I'm going to talk more specifically about building an autograder for Gradescope. Yeah, so just to kind of frame things again, I have just a screenshot of the Gradescope autograder results UI so that we can kind of talk about how different pieces of the autograder implement pieces of functionality. So in this case, I have a list of test cases. Some tests have passed, some tests have failed. There's points associated with each test case. Some of the test cases have output associated with them. like textual output. And then some test cases have a visibility setting that prevents them from being shown right away. And so that's kind of the overall, those are some of the relevant features when you're building your autograder on Gradescope. So when you are building your autograder on Gradescope, you want to start with the autograder documentation. Try and read through that closely. And if you have any questions, always feel free to reach out to us, and we can help you try to understand what you need to do. But at a high level, to build an autograder on Gradescope, you need to define how to set up your autograder environment, how to actually evaluate the student's code, how do you execute it, and what are you looking for it in the output from the students, and then how do you actually, what results do you want to give back to students, what do you want them to see? So once you've defined this in your autograder zip file, Gradescope will handle for you the accepting of student submissions, executing your autograder on those submissions, and presenting results back to the students. And you want to also check out this autograder specifications page for more detailed information. I'm just going to open this up real quick because I might want to refer to it in a second, because we're going to talk a little bit more about the details now. So yeah, as Olia had shown, the way you upload your autograders to Gradescope is within a zip file. So any files that you need for your autograder are going to be inside that zip file. In particular, there's going to be a setup script in there that you can use to install anything that you need in your autograder image. That happens to be a shell script because we are running on top of Linux. So you would need to be able to install anything you want to install within a Linux environment. So anything you want to install, such as like language runtimes or build tools or like libraries, packages, any other like one-time setup you want to do, such as like setting up testing data, setting up a database. There's all sorts of things that you can do because at the end of the day, you're just writing a shell script in a Linux environment. And then any files that you put in your zip file will be put in a particular directory inside the autograder environment. It's going to be like /autograder/source. And then at runtime, when the autograder runs, that'll be available. So things like test cases, test data, etc., will be in that directory. And as Olia had mentioned, we recently rolled out a feature to have selectable base images. And so one of the things that you can do with that is that now we actually have the option to choose base images that have Java built in. And we might do that with other programming languages in the future as well, because it just kind of helps save some of the setup time. Because when you can install anything you want in your setup script, but then every time you re-upload your autograder, it's going to have to kind of run through that whole process. And so if you're using a common language such as Java or Python, you can use a base image that has that already included. And then, even if you say try to install that language in your setup script, it won't need to do anything because it's already there. So that just kind of helps save a little bit of time and save on time when you're iterating on your autograder. So the next file that's going to be inside your autograder zip file is this run autograder script. And that can be an executable file in any language, because at this point, this script runs each time the student submits. So at this point, you've already, the setup file has been run, and you kind of have an autograder image tailored to your assignment. So let's say if you wanted to install Ruby in your autograder setup script, and then you want to write your autograder in Ruby, that this run autograder script can be written in Ruby. In practice, I think most of the time it still ends up being a bash script, just because you end up needing to do things like copy files around to set up the environment correctly. So, and this is the entry point for your autograder. So like each time the student submits, this script will get run. And you can do anything you want within this script. The only requirement is that at the end of it all, you have to produce a results.json file, which defines the results that are going to be shown to the students. And so we'll talk a little bit about that next. And so just briefly, showing this, there's a sort of a setup phase where you're copying, say, the student submission to a particular source directory. So in general, the student submission goes in this directory. and you can move it around wherever you need it to be to actually run your autograder. And then, you can do anything you want, like, run Python or run any other language, or like, and run something in a different language if like your actual autograder like code lives in a different file. Okay. And so the autograder output, at the end of the autograder run, it should produce a results.json file. So essentially, all that really is just a list of test cases and some metadata about them that's going to be displayed to the users. And so I'm going to go over here and over to the documentation and show kind of the format of what that looks like. Let's zoom this a little bit. So a lot of this stuff is optional. The important thing is that you will ideally have a list of test cases. And then each test case should have a score for how many points the student earned for that test case, a max score so that we can have a denominator for that fraction. A test name is important so that the students will know like what they were being tested on. And there's other optional things like test numbers if you want to order things in a particular order. Output will contain any output that you want the students to see. There's other things like tags, visibility, in case you want to control when the student can actually see the test results. And there's other like extra metadata that you can store. And some of these same fields show up at the top level too, in case you don't want, for whatever reason, like you can override the overall score at the top level so that, maybe some of the autograder points is one value, but some of each test case might be one value, but then maybe you apply some sort of formula afterwards to compute a different number, like say you have late penalties or something like that. You can compute that within your autograder as well. And then lastly, there is also a leaderboard section, as Olya mentioned. If that makes sense for your assignment, then you can store some data here. And this will essentially just set up a sortable table for the students so they can see, what score they got on, different dimensions and how they ranked on each of these dimensions. And so, how do we actually generate this file? There's a few different ways. If there's the most basic thing is, most programming languages will either have native JSON support. And just to like recap real quick, in case you've never heard of JSON, that's just a JavaScript object notation. And it's essentially just this, it's just a simple notation for defining data. And so most programming languages will have some kind of support for generating JSON output. And so, similar to that Fibonacci example I showed earlier, you can just, keep track of test results in some kind of like list or array data structure with some kind of like, arbitrary, like say like hash map type data inside, or, structs, whatever your programming language kind of has for storing arbitrary data. And then at the end of your test run, you can sort of convert that into JSON format and produce that for Gradescope. If you are using Python, we do have a Gradescope utils package that integrates with the Python unit test framework to produce that JSON format as well. And I'll show how you can use that in a second. And then beyond that, we also have a bunch of community provided resources for other languages and frameworks. So, you don't necessarily have to use our examples. There's many other examples that other users have shared with us as well. So there's a few different Java examples, there's different C++ examples, a few different Python examples, R, all sorts of things that people have done with Gradescope. And if you also have anything that you want to share with us, please feel free to let us know, and then we can add it to this page, or you can actually submit a pull request on GitHub as well to add links to this page. And then, if say you don't have any examples you want to use, or any frameworks, you can consider, building your own sort of structure or integrating with a testing framework that you would like to use. You don't necessarily have to use a testing framework, especially if you're just getting started. It may make more sense to just kind of roll your own thing so that you kind of build what works for you and what you need. But those are all just kind of some options that you have. And then now, so to show some of the examples, so this is, within our Gradescope autograder documentation, we have a few different examples, the most prominent one being the Python example. And so this is just kind of going into some of the files in that example to show how you can use the Gradescope utils package to produce JSON formatted output for Gradescope. So there's a few handy features of this package. One of them is this JSON test runner, which essentially wraps your test suite and produces output in a different format that happens to be the JSON format that Gradescope uses to represent autograder results. And so this is kind of showing an example of how to use that that class with the unit test testing framework. And then the other thing that it provides is these decorators that let you annotate each test case with some metadata about the test that will be relevant for Gradescope. So, things like weights and test numbers, you can also set visibility this way. Because basically, a unit testing framework is not necessarily exactly the same thing as an autograder. So, in a software testing world, nobody has anything like point values, so we have to kind of add that on top. And so, if you kind of take a look at the documentation, there's a few different decorators that are available, and there's some other documentation examples here. So just to quickly run through, so some of the other decorators that are available are, you can set the visibility of a test, you can set tags, and you can also define leaderboard, like a particular test case to be a leaderboard value, and you can also assign partial credit. So that was a little bit unique because generally if a test passes or fails, they either get full or zero credit. But to use this decorator, you can actually set a particular decimal value as the value for that test case. So if that's something that's useful for your test cases, then that's something you can do. And then we have a few more example tests in this example. The one thing I want to highlight, so most of these are just kind of simple, like passing different arguments to the student's code and checking that things work. One thing that's useful is that in our example, we have one test that just checks the submitted files. So just to make sure that the students actually submitted the files that you expected, so that if, say, they're missing certain files that are required, we can kind of notify them early with a clear message rather than, say, like generating some kind of exception because the file was missing that we were expecting. And then another thing that I wanted to highlight in particular is the sort of integration test that we have here. So, as I mentioned earlier, the calculator example, the idea is that the student should write some code that kind of responds interactively to the input that the user provides. And so to do that here, to test that, we're running the student's code in a subprocess and communicating with it over standard input and standard output. So, we can pass in inputs that we want the code to respond with, and then check that the output matches what we expect. And so, that can be a useful technique in general, especially similar to that sort of the diff style grading that was mentioned earlier. If your student's code does not necessarily map neatly into units that can be tested, but perhaps it produces output like this, that might be a way to test that code as well. And so, just to briefly talk about under the hood, so typically testing frameworks often provide some way to customize their output format or hook into the events that they generate as they're going through the testing lifecycle. And so for us, Gradescope Utils provides a way to customize the output to use a JSON format instead of the default text format, and then also add some decorators which can be used to customize the metadata that ends up in that JSON. And the same principle can be applied to other testing frameworks as well. Like most frameworks will have some ways to hook into this process. So if you're using some other programming language or some other testing framework, that might be something that you would want to investigate for your own tools. So some other resources that we have, there's that community resources page that I linked to earlier. We have a few different examples on our documentation site. I don't think we'll go into it now because we're kind of running short on time. But I do want to mention that, that we do have an example of a sort of diff-based autograder. So like that, the idea of running the student's code, checking the output to see that it matches a particular expected output. We have a whole example that does that, and essentially, if that's the type of assignment that you have, you can actually just take this example and use it. And you just configure it by providing certain configuration files, and then you don't have to actually write any code if this example works for you the way that you want it to work. And then just a brief note on debugging. So one of the things that's neat about Gradescope is because we have this whole containerized setup for you. If there's any issues with an autograder, one of the things that you can do on Gradescope is debug. We have this feature called debug via SSH. So essentially, you can quickly open up an interactive terminal session with that autograder and student submission checked out. So this is a completely new environment with nothing in it other than the autograder and student submission. You can run the autograder and see what it produces. You can look at what code the student actually submitted. You can make edits and rerun the autograder interactively and see if you can kind of figure out what went wrong. So sometimes it depends on the student, of course. Sometimes the students will sometimes there's an issue with the student's code that you don't know how to they might ask you like, why is my test failing? And then you can kind of tell them this is maybe you had a syntax error on this line. And so this debug via SSH feature gives you an interactive way to do that. And then the other thing is it can be useful. So we captured anything that's printed to standard output and show that to you, but hide it from students. So if it's useful, you can print some debugging information in your autograder process to standard output, so that if you have some diagnostic information that can help you debug, that can be useful as well. So you don't have to even necessarily pop into a debugging session right away. Okay. And then, sorry, we're running out of time, but I just wanted to mention some quick tips on setting up your autograder. In general, I think it's really helpful to give feedback early and make it actionable. So, do as much error handling as you can early in the process, so that you sanity check things like the files that are submitted, so that students will get a helpful error message and not a weird error message like, it failed to import some class name that they're not really sure about, or like they don't know why it failed to import something. And then in general, it's a good idea to isolate test failures to thing being tested, so that they don't get penalized multiple times for the same mistake. And there's some kind of suggestions on how to do that, such as like timing out individual tests, or using a higher level scripting language to coordinate the tests. And then the last kind of suggestion is that you can use the visibility settings on Gradescope to keep some tests hidden, so that students don't rely on the autograder to do their assignment, but rather like you can make it so they don't necessarily see their full score until after the assignment is due. Okay, so I guess if there's any questions that we want to handle live, we can take that now.
Yes. So one question from John is, do you have any best practices around security? As the students and the test cases code both exist in the same process space, they probably have the ability to access the test scripts and other files that they should not be able to access.
Yeah, so that's a good question. It's hard because, like you said, the student's code, like depending on how you've set it up, the student's code will likely exist in the same process as your autograder and will have access to the same files. I think so. If you can try to isolate things in such a way that with like file permissions, and you can potentially use a different user to run the auto grading rather than the default, that's one way you can try to isolate things. But at the end of the day, the student's code will be passed the input that you're trying to pass to it. So it's a little bit tricky to do that. One of the things that by default we hide standard output, so that if like students are just blindly like printing anything that gets passed to their functions, that won't get shown to the students by default. So that's kind of like a slight security feature there. But Yeah, a lot of it depends on how your tests are set up.
Awesome. This one might just be more of a feature request, but I wanted to double check with you. We had a couple of people ask about, let me make sure I get the question, HTML output and HTML output option for test cases.
Mm-hmm.
Is that possible, or is that more of a feature request?
Yeah, so that's more of a feature request. I think that there are some formatting options that are available, but it's somewhat undocumented. And then in the future, we do want to have a better formatting system, but that is a feature that we would have to actually develop at some point. Yeah,
Awesome.
and I think HTML output would probably be one good way to do it, but we would just have to, like, there's obviously security concerns with including arbitrary HTML on a web page on Gradescope, so we have to kind of do some sanitization there.
Thank you. The next question I'll actually answer. So the question is, can you create an assignment that's a mixture of programming problems and regular written problems? So there's basically two different ways to do it. First of all, with a programming assignment, you can have students submit multiple files of different types. So you could have a student submit a PDF file that has answers to some written problems, as well as a code file that is called upon by your autograder and then is autograded, all under a single programming assignment. The only downside of that is that your students won't be able to assign each page of their PDF to a question as they would with a regular homework assignment type on Gradescope. So if that aspect is important to you, then you might consider having two separate assignments, one programming assignment for the code and one homework assignment for the PDF. If it's not as important for you to be taken to the right page of the student's PDF as you're grading each question, then you can just combine that under a single programming assignment. And you would basically just use the manual grading option to define as many questions as you have on that PDF and grade each of those questions on a separate rubric and just have students submit the PDF to the programming assignment. And I think those are all of the questions that we have at the moment.
I guess if that's, I just wanted to go quickly back to the sort of academic dishonesty or students trying to like exfiltrate information type question. So I guess another suggestion I would have in general is like you said, it is kind of an academic dishonesty case, and you kind of hope that that doesn't happen, but you know that somebody's going to disappoint you at some point. And I think that one thing that's a good idea in general is, because Gradescope has these great manual grading features as well, it's a good idea to just kind of make that part of your process. So like, hopefully if you want to just kind of give general stylistic feedback to your students, you can do that. But then also like as you're that way, when you're reading through the student's code, you can hopefully kind of just come across like if there's something like obvious that they're doing to try to cheat, you will hopefully come across that just in your audit of the student's code.
Great.
Okay,
So I think
Selenium.
Yeah, do you want to answer the Selenium question?
Yeah, I can. I mean, I don't have any specific tips. The important thing in general is that with autograders, you just have to know that the autograder runs in a headless environment. So the tools that require graphical interfaces may not work out of the box. However, things like Selenium typically have ways, like for instance, like with Selenium, you can use like Chrome headless or like headless versions of browsers, and it should work. I haven't tried to do it myself, but I know that other people have, and I know that personally, like for Gradescope, we also use something Selenium based to do our own testing. So, in principle, I think it should work as long as you make sure that it's running in a headless mode.
Awesome. So I think that brings us to the end of our webinar. Thank you everybody so much for joining us. We will be following up with an email that includes a recording, some of the resources that we shared throughout the webinar in the chat. So you'll have links to all of those. So look for that email probably at the start of next week, just to give us some time to compile answers to any questions that we may want to follow up on. If any of you have further questions about code autograders, programming assignments, or anything Gradescope related, please just send them over to our team at help@gradescope.com. It's our support team. I put the email in the chat, and we'd be happy to help with any additional questions that you have. Thank you everyone again, and hope that you have a good rest of your day.